Unit 7, Exponents and Scientific Notation. This lesson begins a new unit, obviously on exponents, and we're going to start with this lesson 871, Circles, Exponent Review. In this lesson, you'll use exponents to describe repeated multiplication and explain the meaning of an expression with an exponent. In your notebooks, you're on page 110, and I hope you've had a chance to go through the Desmos activity where you saw a lot of objects that were being multiplied by 2 or multiplied by 3 that helped you to understand what happened at different stages of that separation or that division. We have 2 learning goals today. One of them is to use exponents to describe repeated multiplication. And also to explain the meaning of an expression with an exponent. Explain the meaning of an expression with an exponent. Let's start with our first one. Use exponents to describe repeated multiplication. Now, exponents make it easy to show repeated multiplication. It is a lot easier to write 2 to the 6th power than to write 2 out as a factor 6 times. 2 times 2 times 2 times 2 times 2 times 2. I mean, 6 is bad enough, but imagine writing 2 to the 100th power. 2 times 2 times 2 times 2 times 2, on and on and on, 100 times with 2 as a factor. So we're going to practice that repeated multiplication in these examples here. For each expression below, write an equivalent expression that uses exponents. All right, well, equivalent just means another expression that's equal in value to this one. Let's take a look at the repeated multiplication we see in this first box. So I see 7 repeated as a factor 1, 2, 3, 4, 5 times. So 7 is the number that's being repeated, and because it's being repeated 1, 2, 3, 4, 5 times, our exponent is 5. By the way, we're going to be doing this a lot in this unit. When you see all of the factors, that's called expanded form. And when you see it written with an exponent, that's obviously exponential form. This one's a little bit different. I see some repeated multiplication, but it's all jumbled up. So let's use some highlighter to gather together things, bases that are the same, or factors that are the same. I see that 5 is repeated as a factor 1, 2, 3, 4 times. So I can express that part. 5 is the factor that's being repeated, and 4 is the number of times it's repeated there. And because this is all multiplication, I can multiply that to what I see in this other repeated factor. So this really means 5 times 5 times 5 times 5 times 8's repeated 1, 2, 3 times. So these mean the same thing. 5 appears as a factor 4 times, 8 appears as a factor 3 times. This is just a nice shorthand way of showing it. In this example, I want to be really careful because repeated multiplication is what we're talking about. As soon as we throw in any other operation, then we got ourselves kind of a problem. So even though I see the number 10, 1, 2, 3, 4, 5 times, it's not repeated multiplication all those times. I have to be aware of this. I have 10 repeated as a factor 3 times on the left side of that plus sign. So I can write this 10 times 10 times 10. Those are all multiplied together. And I can see 10 times 10 repeated as a factor On the right side of this plus sign, so 10 is repeated as a factor 2 times over here, but I have to be really careful not to say that those are multiplied together like they were over here. I'm going to bring down this plus sign. And I'm going to fight the urge to just smush all of these together. It's repeated multiplication that I can use exponents for. As soon as we cross a line into addition, I can't put those together anymore. So that's how we can use exponents to describe repeated multiplication. Let's move on to our other learning target, explaining the meaning of an expression with an exponent. Let's scooch up a bit. So in the activity that you had today, there were different stages of division where there was an object that was being divided and divided and divided again. Consider this situation. Each day, the number of grains of rice you have triples. Now, when we say triples, we mean that we're multiplying by 3 every day. So whatever we have one day, if we multiply that by 3, that's how much we'll have the next day. And we're told that on day 1, you have 3 grains of rice. On day 2, you're told that it tripled, so whatever you had on day 1, that tripled. And now you have 9 grains of rice. Now, I'm going to come back and write this as an exponent so that we can notice a pattern here. I'm going to go one more here. Day 3, I'm going to have the same that I had on day 2, but I'm going to multiply that by 3 again because it tripled again. And that's the same as saying 3 to the 3rd power. So on what day will you have 243 grains of rice? Well, I've got to start here. On day 1, I had 3. On day 2, I had 3 times 3, or 9. On day 3, that tripled again. I had 27. I guess I need to keep going until I have 243 grains of rice. Let's try it out. On day 4, I had all of that from day 3, and then that tripled. That's 3 to the 4th power. If I multiply 27 by, if I triple the 27, I get 81. So we're not quite there yet, but we're going for 243 grains of rice. Let me go one more here. Day 5, I'm just going to expand this out just so we see the connection between this repeated multiplication and this exponent. And if you were to grab your calculator and triple 81, you would in fact end up with 243. And that's what we were looking for. So on day 5, I had 243 grains of rice. Now I want to point something out to you that might help us with the next couple of problems. On day 5, 3 appeared as a factor 5 times. Our exponent was 5. And that worked for day 4, the exponent was 4, day 3, the exponent was 3, and so on. So the day number is actually the exponent that I'm going to put on the 3. That's how many times I've used 3 as a factor. So we don't have to work too hard to figure out the day that we're going to have 3 to the 13th power grains of rice. Well, on day 5, we had 3 to the 5th power grains of rice. So it must be on the 13th day. That's when I've multiplied 3 by itself 13 times. I've tripled something 13 times. Now the next one gets a little bit tricky. How many grains of rice will you have 2 days after you have this much rice? Well, this is a really big number. That's day 13. And just so you can see what it is, I'm going to go ahead and calculate that. 3, we talked about where the exponent key was last week. So this is a really impressive number, 1,594,323. And let's think for just a moment about what we're going to do to that number to get to day 15. Well, for day 14, we're going to triple it. So we'll take that number and multiply it by 3. And to get to day 15, which is what we're aiming for, that's 2 days after, I'm going to multiply it by 3 again. So I have 3 used as a factor 13 times, and then 14 times, and then 15 times, because each day we're multiplying by 3 again. So 2 days after, on day 15, I'll have 3 to the 15th power. And just because it's fun, let's go ahead and find out what that would be. So 14,348,908. And I got that by taking whatever day 13 had and just tripling that and tripling it again. I really multiplied by 9 to get to day 15. So that's how much I would have on day 15. So when's it useful to express a number or expression with exponents? Well, it's useful when there is repeated multiplication. Okay, so we've explained the meaning of an expression with an exponent. This really means I've tripled something 15 times. And we've also used exponents to describe repeated multiplication. You should be ready for tonight's practice work.